Hello friends, today I am going to discuss uh, one of the final model, like a final model of univariate time series, SARIMA. Previous video I have already discussed. So if you do not see my previous video like ARIMA model, so please watch, then it will be easy to understand. So in this chapter I am discussing like a univariate time series model breakdowns. So ARIMA components, like in the previous video we have already covered, like a model autoregressive progressions, moving average components, and integrations like a differentiation. And a common process of the time series is still missing from this, like a seasonality. So seasonality, so we can see that there is only one model more complicated than the SARIMA, and one more is the SARIMAX model. But SARIMAX we use like multivariate. Most of the time we use in the multivariate. So first, so if you compare like a SARIMAX model is quite different from SARIMA. So it uses the external variable that correlated with the target variable, and SARIMAX is a very powerful tool as well, but it can be applied only if you have an external variable. So using external variable, it makes the model not a univariate time series model. But we try to understand here like the power of the SARIMA model is that it needs to use only the history of the target variable, which can be applied to a very many cases of forecasting. So SARIMA model it is a combined of the different process in one and the same model. So the model definitions look we have already looked like a very complex mathematically. Like if I write here the yt will equal to ut plus nt, and another the small phi p bracket start l, now the capital phi p ls delta d delta s d capital D. One is the previous I told you the d like a small d, and here is the capital D ut will equal to capital A t theta q l theta capital Q ls and eta d. So just this model means we are try to understand like regular AR part with the coefficient of the small phi p, and seasonal AR part with the coefficient of capital phi p, a regular MA part with the coefficient of theta q small theta, and seasonal MA part the coefficient of theta capital Q. So the regular integration part indicated by order D, and the seasonal integration part indicated by order D capital D, and coefficient of seasonality S. So as you can see, adding seasonality to The ARIMA model makes the model much more complex. The seasonality is not just one building block added to the previous model. There is a seasonal part added for each of the building block. This makes the lag. The lag selections of the SARIMA model also much more difficult. The same hyperparameters as before still need to be decided on. So P for AR order, Q for MA order, I for differentiation order, and to this the added three more order like a P for the seasonal AR order, Q for seasonal MA order, D for seasonal differentiation. And lastly, the choice for a parameter is the seasonal period must be made, and this is not a hyperparameter like the other order. S should not be tested using a grid search, rather it should be decided based on a logic. The S is the periodicity of seasonality. If you work with monthly data, you should choose like a 12. If you work with a weekly data, you should choose 52, etc. So let's see, I am going to collect here like some important. I am using a Google Colab and I am collecting a data from a Kaggle. So import pandas as PD, import matplot as PLT. So I have look like this has been imported, and after that import OS as a operating systems, OS environment Kaggle underscore config underscore dir, and then content slash drive my drive Kaggle. So it has been done, and next percentage cd content drive my drive Kaggle has been, and then Kaggle sales I have taken. Now after that on zip file, so it is converting into the zip, unzipped, no zip. So now data has been okay. So I think I did get some problem to collecting this data. So let's see. I think so. So I have done. So let's see. One minute, just data. I think it's possible to, don't worry. Let's see, now it has been collected, and this one has been done, unzip had been done, and now I am collecting this data. So zip and dot let's see the revoke, no thanks, setting the new runtime, revoke the okay. So your Google one minute, just it's not a problem, it's a very simple. So I hope content I have got it. some problem to collecting a data. So now it's, yeah, you use and chip. So let's try one more. I hope. Locate in this Kaggle use and zip, no zip files, and here. So why it is not working? Don't worry, because PD not defined. PD name is not defined. It's has been worked. Okay. So Panda is not working. Don't worry. So I have already done everything. So I have gotten the some problem. Don't worry. But you can collect the data. Sometime internet not working properly. So let's see. Just I have already done this project. So now the data dot group by and data dot sum ax dot data weekly underscore cells and dot plot ax dot set underscore y level and weekly data. Just I have done and I have gotten this forecasting. So just I have seen like data, I have date sums and ax at x-axis represent like a data and weekly cells we can see here like 12/11/2010 you can see the 2 hike and 6/1/2012 is also you can see the really 2 high. Now after that, so let's I have gotten and just I have already plotted. So let's first try. The first mode is ARIMA 111 and 111 52 weeks like models. So this notations indicate at the order 1 for the each of the hyperparameters. The seasonality of 52 because you are working with weekly data, and we will forecasting 10 steps out rather than doing the 10 1 steps forecast. So this is a case of multiple forecasting. Excuse me. So how to fit the models and obtain a plot of the performance on the test set. So first we will also obtain like a R square score on the test data and need to the import random seeds 1 2 3 4 5 import stats model dot API from scalar matrices import R square and train this data like a weekly and taking a and means from the last end and test data like a from the beginning. Skip the from beginning, here we are skipping the last. Move the SM TSA state space, this one, seasonal order like this, residuals, mode fit, forecasting, RES forecast step 10. plot list plt dot plot list forecast. So we could see here this one with the R square test also given like this. 73%, it's a good excuse me. So in this version, without any hyperparameter optimizations, the SARIMA model obtained an R square score like a 73%. This means that the model can explain 73% of variations in the test data. This is a very promising score. So the season if you see this score is the already quite good, is probably the flexibility of the SARIMA model, the fact that it is a combination of multiple effects make it fit to many different underlying process. And if you want to improve, so you can use improve using a grid search of the hyperparameters. So speed up code, and you will notice cross validations in a grid search here. Speed of executions is also important aspect of the machine learning. So this is a way we can easily understand. But I want to see here some residuals, predictive performance optimizations, SARIMA. So you could see RES dot summary. So SARI max result. You could see here the dependent variable like a weekly sales, number of observations I have taken 133, models it has been given like this, likelihood negative, AIC, BIC is here, HQIC is here. So all are the near about. I think time you can see just we have already run, and this is a sample I have taken 2/5/2010 to 8/17/8/2012, and you can get the ARL1 MA moving average and ARS MAS. So all coefficients, most of the one coefficient like a MA coefficient, sigma is also given, and one most important your p value is not at the 0, so you can easily understand is it stationary and not stationary. And L-junk box probability like a 0, heteroscedasticity like a 1.51, probability on the two-sided 29, skewness and kurtosis. So this is a way and to understand SARIMA model, and I am really sorry, just means some internet connectivity problem, so I am trying to get your data is not, but I have already done this project, so I will discuss. You can do the same procedure, don't worry, it works. Okay, thank you very much. I hope it is helping someone